Hello, dear friends. Let's solve this summer 2025 AS Physics MCQ paper, component 2.1. Which quantity is a vector? We know weight is a vector. 4 students A, B, C, and D have complete an experiment to determine the acceleration of it. Each student repeated the experiment 3 times. Determine the values of G as shown in the table. Okay. Which set of results has high precision and low accuracy? So first we have to recall the understanding what is accuracy, how close to the actual value, what is what is precision, precise, how detailed to the actual value. Okay, how detailed, how good in detail the measured values. Now just by looking, we have to find which is low accurate and high precise. Okay. Okay, so first we will find all the average of all this exponent 1 and exponent 2 of all the candidates A, B, C, D. So it's 8.3, B is 9.83, sorry, it should have been 9.8, not 9.83. C is 9.8, D is 10.1. Now, if you take option C and D, if you find the average, you will get 9.83, and for D, you will get 10.13. But the raw data, least significant figure in raw data, option C is only 2. So that's why significant figure is given only 2. Option D, all the 3 values have 3 significant figure. So you have the result, average also 3 significant figure. Now, just by looking, we can tell that option C is more accurate and more precise. Option D is less accurate compared to all the other, because actual value is 9.81, but this is not even close to 9.81 compared to other values. So D is less accurate but more precise. Why more precise? It has more significant figures. So option D is less accurate, more precise. Yeah. Diameter of the ball is measured as 5.26. What is absolute uncertainty in the volume of the ball? Okay. So first we have to find the volume of the ball. We cannot use 4 by 3 pi r cube because only the diameter is given, not radius. So we'll try to convert the formula to diameter. You know this formula already. 4 by 3 pi r cube, instead of r cube, we are writing d by 2 the whole cube. So we'll get 4 by 3 pi d cube by 2 cube, which is 8. So 3 into 8 is 24. 4 divided by 24 is 1 by 3. So it's just 1 by 3 pi d cube. Okay. Now we'll figure out the volume. So 1 by 3 pi 5.26 cube. Remember, I didn't convert this into meter because looking at the options, all of them are in centimeter cube. So we do not need to convert into meter cube. So volume is 76.2 centimeter cube. Now we need to figure out what is absolute uncertainty in the volume of the ball. How do we find absolute uncertainty when it comes to multiplication and division? Delta V by V is number of times in the power, which is 3. 3 into delta D by D, diameter, because it's volume of the sphere is, ball is d cube, 1 by 3 pi d cube. So that's why 3 into delta D by D. Now we have to find delta V. So we'll bring this V to the other side. 3 into delta D by D. So we already know 76.2 into 3 into delta D, which is 0.02 centimeter cube, divided by D 5.26 centimeter cube. So if you work out the answer, we'll get 0.869 centimeter cube. Raw data is only 3 significant figures. So if you round it up, 0.87. Two vectors x and y are shown. What are the directions of x plus y and x minus y? Okay, first we will figure out x plus y. So here is x, and we'll put tail of the y to head of the x. Here is y. So if you connect tail of x and head of y, we get x plus y. Okay. Now we want x minus y. So instead of x minus y, let's take x. Okay. Y is this. So minus y is this. So this is just x plus, open the bracket, minus y, close the bracket. Okay, like that. Eventually it is x minus y only. So this is x plus y. X plus minus y. So it's horizontal to right and vertical to up. So option B. Ball is projected vertically downwards with an initial velocity of 20 meter per second. Air resistance is negligible. What is the displacement from its initial position of the ball after a time of 1.5 second? So we can directly use S equal to ut plus half at square. U is 20 meter per second. Time is 1.5 plus half A is 10 meter per second square into T is 1.5 square. So it's 30 plus 11.25 meter. So I'll get 41.25 meter. Raw data has only two significant figures, so it's 41. It's a traditional question. We know that distance, speed is distance by time. So time is distance by speed. The distance is twice because it has to start from here, go, hit back, and then come back. So it's twice the distance. 2 into 150 meter divided by 3 into 10 power 8. So 110 power minus 8 second. But none of the answer is in this format. It's either in nanosecond or in millisecond. So this value we can see it's close to millisecond because 100 to 0 multiplied by 10 power minus 8. So if we cancel this to 0, we'll get 10 power minus 6. So I can write it into 1 into 10 power minus 6, which is 1 microsecond. Which equation of uniformly accelerated motion can be derived using only the gradient of velocity time graph? Oh, nice. In velocity time graph, gradient is acceleration. If you take velocity time graph, v versus t, find the gradient, which is final velocity minus initial velocity, v minus u by t. So if we rewrite this, we will get v minus u equal to at, which is v equal to u plus at. Option C. Nice. An object is projected horizontally from a table at a time t equal to 0. Object falls in uniform gravitational field. Air resistance is negligible. Okay. Graphs P, Q, R, and S are velocity time graphs. Which graph represents the horizontal and vertical components of the velocity of a object? Okay. We know that the horizontal velocity is not going to change. Gravity acts only in vertical. So horizontal velocity, initial horizontal velocity will remain constant throughout the motion. So I think option Q, where V is just constant for horizontal. Okay. For vertical, air resistance is negligible. For vertical, velocity will increase. But question is, will it increase like P or will it increase like S? Okay. It will increase like P because acceleration is constant. What is a constant value? 9.81 meter per second square. So velocity will increase with a constant gradient. So P. Remember the link from the last question, yes. So P is vertical velocity. Why? Acceleration is constant, so the gradient is constant. So it's a straight line. So I think horizontal Q, vertical P. So option A, yes. What is always conserved in elastic collision? Total kinetic energy is conserved in elastic collision. Remember, total velocity is not conserved in elastic collision. Okay. Only the velocity of approach is equal to velocity of separation, the relative velocity, not the total velocity. Okay. Good. Nice question. A firework travels vertically up in the air. Gases are pushed vertically downwards from the firework. Several forces that act on the firework gases and gas assumption. Which forces are Newton's third law of air? So what is the condition for Newton's third law of air? It should be equal and opposite. Okay. Air resistance and forces on gases, they are in the same side. They are not equal and opposite. So not A. Air resistance and thrust, they are opposite, but they are not equal. So not B. Forces on gases and thrust. Yeah, they are opposite. And yes, they are equal. Thrust and weight, they also again act on same direction. So option C. Forces on gases and thrust. So someone might get little confused about option B, air resistance and thrust. If air resistance is equal to thrust, then it will travel only in a constant velocity, mean it has reached terminal velocity. Okay. Is it mentioned anywhere it's in equilibrium? No. So that's not possible. So only option C is right answer. Yes. Okay. Two blocks K and L slide towards each other along a horizontal frictionless surface. The diagram shows the momentum of the two blocks just before they collide. During the collision, the blocks are in contact with each other for 0.084 seconds. After the collision block, so what is the magnitude of the average force exerted on the L on block L by block K? Okay. Okay, let's create some space. Now, two blocks are here, K and L. Okay. So we will take any one direction positive. So we can take this direction positive. We are interested in finding the force from K to L. So we'll take the force direction positive. So K is coming with 0.72 kilogram per second. It's supposed to be kilogram meter per second. Yeah, okay. And L is coming with in the opposite direction, 0.46 kilogram meter per second. And L is going back 0.12 kilogram meter per second. Okay. Now, what is the force exerted on L by K? So, in this direction for 0.084 second. Okay. We know the equation Ft is mv minus mu. We'll just rewrite this equation. F is mv minus mu divided by T. Remember, mv is in this direction 0.12. That is positive we took. So, mu must be negative minus 0.46. So 0.12 minus 0.46 divided by 0.8084, 6.9 Newton. Okay. So you can take the opposite direction also positive. Only you have to be careful and deal the F also negative. So you will get the answer. Proposed a flying machine that would work like a screw to lift the pilot into the air. The screw is rotated by the pilot. Okay. The machine and the pilot together have total mass of 120. Which is the useful output power must the pilot provide to move vertically upwards with a constant speed of 2.5 meter per second. Okay. So first thing we have to understand that it is going with a constant velocity, meaning that whatever the upward force is equal to its weight. So it is going in a constant velocity. No resultant force upward. Okay. So the upward force must be equal to the weight. So force is the weight. Okay. We know the formula power is force into velocity. If you do not know this formula, we know power is energy by time. Okay. And energy is force into distance. So distance by time is velocity. So power is force into velocity. Okay. So force, the upward force is equal to the weight. That then only it's going in a constant speed. So it's mass into 9.8 gravity, 120 kg into 9.8 into velocity 2.5. And we'll get multiply 2940 watt rounded to 2900 watt. Yeah. Which row describes a pair of forces that forms a equal and opposite? So option B. Uniform cylinder of weight 25 newtons. Okay, we'll understand the problem. Now there is some weight. If you hang this weight into force meter or Newton meter, it shows 25 Newton. Now if you dip this weight or mass into the water, then it shows 10 Newton. Why? Some upthrust in the water. Okay. So reading on the Newton meter is weight minus upthrust in the water. Okay. We know the upthrust in the water is rho GV. Now we have to find what is upthrust in the water in the first case. So simply weight minus the reading. Okay. So I hope I'm explaining this correctly. Now if you hang it directly, it shows 25 Newton. Now if we dip it into the water, then in the liquid, then it shows 10 Newton. So how much upthrust is provided? 25 minus 10, 15 Newton. Okay. Now they're asking the liquid has been replaced with 10% greater density of the water than density of the water. What will be the new reading on the Newton meter? So what is upthrust to? First we have to find. We know that upthrust is rho GV. In the first case and second case, only one thing is changing, which is rho. So the density of second liquid is 110% density of first liquid. So it is 1.1 times density of first liquid. So if you put that in equation, so we know that rho GV is just density of first liquid and upthrust in the first liquid. So it will be just 1.1 times the upthrust of the first liquid. Okay. So 1.1 into upthrust of the first liquid, which is 15 Newton. The rho GV is 15 Newton. So 1.1 into 15, which is 16.5 Newton. Now, how do we find the reading? Weight minus 16.5. So 25 minus 16.5, which is 8.5 Newton. Yeah. Sorry. A student balances a 30 centimeter ruler on a fulcrum set at the mark 15 centimeter. She then places a 50-gram masses on the 20 centimeter mark, 20 gram. Which mass should she place? Okay. So we know this concept. Distance from the pivot multiplied by the force must be equal to both sides. All the clockwise moment is equal to all the anti-clockwise moment. So we'll find the distance from the pivot. 15, it's 7. So from the center, it's 15 minus 7, 8. So second one is 15 minus 11, 4. This one is 23 minus 15, 8. So you have, so what is this mass on the 7 centimeter, which is 8 centimeter from the pivot's position. So 8 into x plus 4 into 20 is equal to 8 into 50. Okay. So we'll just rewrite this equation. 8 into x plus 8 is 400 and x will be 400 minus 80 by 8. Okay. So 40 gram. 40 gram is answer. You might wonder why force is not considered only mass, because gravity acts both directions same 9.8 only. So we can cancel that out. No problem. One more thing. If you just take the distance instead of 15 minus 7, 8 and 15 minus 11, 4 and 23 minus 15, 8, if you just take the direct value, you will get an answer. That's the wrong answer. See, I took 7 into x plus 20 gram masses place 11 and 50 gram masses place 23. Then you get x is 123. If you round it up to 133, it's wrong answer. Yeah, those are reading on the scale, not distance from the pivot. A submarine is at a depth of 130 meter below the surface of the sea. The pressure on the submarine due to the seawater is P. The submarine sinks to a depth of 260 meter below the surface. Assume the density of the seawater is constant. What is the difference between the pressure on the submarine due to the seawater at the two depths? Okay. So now this is surface. In 130 meter, it's P pressure. In another 130 meter, it will reach some pressure. So what is the difference? Just by looking, we can tell it's in 130 meter, it's P. Another 130 meter, it's going to be 2P. The difference between second and first is just P. So option C is the answer. But we will see, we will solve mathematically. Okay. We know pressure is rho GH. First pressure is rho G into 130 meter. Second pressure is rho G into 260 meter. So they are asking difference in pressure P1, sorry, P dash minus P. So it's PG 260 minus PG 130. We'll take PG common. So we will get, sorry, rho G common. We will take 260 minus 130, which is rho G into 130. This is nothing but pressure in the first place. So it's just P. You need weight and change in vertical displacement, because potential energy is mgh, mg is weight. Okay, so in xy it is 3 meter. For 3 meter it's 150 joule. So 1 meter you will take 150 by 3, 50 joule. From y to x, y to z, it's 200 joule for 4 meter. So again here 1 meter is 50 joule. So if you have to find xz, the distance, then it's xy square plus yz square. So 5 meter. Pythagoras theorem. So 5 meter they have sent. So they have to, no, they didn't give. Okay. We found for 1 meter it takes 50 joule because it's the same surface. So 5 meter is going to take 250 joule. And if we choose 250 joule, we are wrong. Why? The question is, how much extra work is done against the frictional force in moving P then Q? So we have to find the difference. which is 250 J minus 150 Joule. So 100 Joule is the right answer. Remember, the question is what is the difference? Not what's the work moving from X to Z directly. What is the difference moving X to Z directly from moving to X to Y, then Y to Z? Okay, momentum of the car of mass M increases from P1 to P2. What is increase in kinetic energy of the car? Okay, so there is a formula directly relating kinetic energy. Kinetic energy is P square by 2M. Okay, if you do not know the formula, we know kinetic energy is half mv square. We'll multiply and divide it by m. So it will not change anything. And mv square into m is m square v square, which is p square. 2 into m is 2m. So it's p square by 2m. Okay. So what they're asking, what is increase in kinetic energy of the cars? So it's final kinetic energy minus initial kinetic energy. So final momentum square by 2m minus initial momentum square by 2m. So option A. Gravitational potential energy is converted into kinetic energy of the parachute. We'll see why all the other options are wrong. Sorry, other options are right. Gravitational potential, option A, gravitational potential energy is converted into kinetic energy of the air. This is right. Option C, gravitational potential energy is converted into thermal energy of the air. Yes, this is also right. Both are literally same, A and C. Gravitational potential energy is converted into thermal energy of the parachute. Yes, the temperature will increase. So only B is wrong. Gravitational potential energy is converted into the kinetic energy of the parachute. Nope. This is before it reaches terminal velocity. You can note down this question because all the points are very important. Student investigates the spring, the variation of the length of the spring with the force applied. The spring is shown. What is the spring constant? Spring constant is F equal to Kx. K is F by X. We need to find the extension. How do we find the extension? I think the original length of the spring is 0.420 meter, where there is no force. When force is 0, that is the original length of the spring. Okay, so in the graph, I'm going to take 2 points, 2.4 and 0.60 to find K. Okay, and you can find X as we have discussed. In this point, extension is 0.60 minus 0.20. So 0.4 meter. So spring constant is F by X. So force we took 2.4. Any point you can select on the graph. 2.4 divided by 0.60 minus 0.20 meter. So, sorry, 6 Newton per meter. Option D. Yeah. The graph shows the variation with force of extension of wire. Which statement is correct? The wire has elastic deformation at point Q. The wire has elastic deformation at point Q. This is right. Okay. Let's see why all the other options are wrong. Along line PQ, the wire obeys Hooke's law. No. In PQ, if you see, it's not a straight line. Okay. So what is Hooke's law? Force is proportional to extension until which that point, that's a force. That's a hook. That's the region where it obeys Hooke's law. Okay. So PQ is not doesn't obey Q Hooke's law. Maybe OP is 0P is 0P obeys Hooke's law. So A is wrong. Along the line RP, the spring constant is equals to extension by force. No, it is force by extension. So B is also wrong. Work done in stretching the wire P is equal to force into extension. It is actually area under the curve. So it's not force into extension. It is force into extension square. So D is also wrong. Uniform metal wire of length L and diameter D has spring constant K. What is Young modulus of the metal? Young modulus is stress by strain. So stress is force by area. Extension is X by L. So if you rewrite this equation, L go to the numerator, A comes to the denominator. So FL divided by XA. So we can separate this equation f divided by x into L divided by A. Fx is spring constant. So K, area is pi r square. In this case, d is given. So pi d square by 4. So if you put these things into equation, instead of f by x, k into L divided by area is pi d square by 4. So the 4 will go to numerator. So it's 4L divided by pi d square. Option D. An aircraft produces a sound at a frequency of 30 hertz. Speed of the sound is 300. What is the speed and direction of the aircraft? We have to use the Doppler effect. Before solving the question, we can see actual frequency is 30 hertz. Observer hears the sound from the aircraft frequency 20 hertz. So frequency is decreasing. So we can say the aircraft is moving away from the observer. So either option C or option A. Okay. If towards observer means frequency would have increased. Okay. So we know that F naught is Fs by Fsv divided by V minus plus or minus Vs. This formula is in the front page. So if it is moving away, then V plus Vs. If it is moving towards, then it is V minus Vs. Okay. V is velocity of sound and Vs is velocity of the source. Okay. So F naught is 20. So 20 hertz is 30 hertz into 330. Yeah. So I just rewrote the equation. So this 330 plus Vs goes to the other side and 20 comes to this side. Then the 330 has to come minus. Okay, it's just rewriting the equation. So if we do, the answer is 495 minus 330, which is 165 meter per second. Yes. Away from observer. C is right. We'll see why others are wrong. All transverse and longitudinal waves require medium for propagation. Wrong. Okay. Transverse wave can propagate without a medium. One good example is electromagnetic wave, light. B. All transfer waves travel at the same speed, but the longitudinal waves can travel at different. Nope. This depends on what is the wave, not what is the type of wave. For example, a ripple in a water pond also a transverse wave. Does it travel fast like the speed of light? No. So B is also wrong. In both transverse waves and longitudinal waves, a particle with zero displacement has a maximum speed. Yes. So we can take a simple pendulum where it will have maximum velocity when it crosses the equilibrium position. You can keep that, remember that. Okay. In longitudinal wave, there is a net moment of particle in the direction of travel of the wave, but there is no net moment of particle in the transverse. This is also wrong. Whether it's a longitudinal wave or transverse wave, in progressive waves, the particles do not move. They just oscillate. They just carry energy. Okay, that's there the definition of wave. Carrying energy without moving. Okay, 25. Option C. Diagram shows a progressive transfer wave on a string at 1 instant time. One point on the string is labeled X, which point 270 degree out of phase with X. What is 270 degree? If you divide it by 90, it's 3/4. So B is 1/4 away, C is 2/4 away, D is 4/4 away. Only A is 3/4 away. So 1, 2, 3. So A is 270 degree out of phase with X. Option A. Which wavelength of electromagnetic radiation in free space could be green light? This you have to memorize. I don't know, I swear. But the option is C. Sorry. Yeah, option is C. Which group contains only waves that can be polarized? All the three waves have sound waves, A, C, D, so they cannot be polarized. Longitudinal wave cannot be polarized. Only transverse wave can be polarized. So option B. Only this has all the transverse waves. one wave has an amplitude of 2a, a second wave has amplitude of a by 2. The waves are otherwise identical. Two waves travel in opposite direction and overlap. What is the ratio? Maximum amplitude of combined wave and minimum amplitude of combined wave. Okay. What is the maximum amplitude? We have to add both amplitude. So 2a plus a by 2, which is 2.5a, otherwise 5 by 2a. Okay. What is the minimum? 2a minus a by 2, which is 1.5a or 3 by 2a. Now they're asking maximum by minimum ratio. So it will be 5 by 2a divided by 3 by 2a. 2 and 2 get cancelled, a and a get cancelled. So 5 by 3. B. Yeah. Light of wavelength 680 nanometer is incident normally on a diffraction grating with 450 lines per millimeter. What is the angle of diffraction of the second order maximum and in the diffraction pattern that is produced? Okay. We know the formula n lambda is d sine theta. We want theta. So n lambda by t sine inverse. So how to find d? In 1 millimeter, it has 450 lines. So what is the width of one line? So 1 millimeter divided by 450. So if we do the calculation, then we get 0.612. So sine inverse of 0.612 is 37.7 degree, 38 degree. Option D. A hollow tube is closed at one end and open at the other. Stationary sound wave of the lowest possible frequency, 820 hertz, is produced on the tube. The speed of the sound in air is 330 meter per second. What is the length of the tube? Okay. So it's lowest possible frequency. So it's fundamental harmonic or fundamental frequency. Okay. In fundamental frequency, only 1/4 of the wave is in the entire length of the tube. Okay. So 1/4 of the wavelength. Lambda by 4 is length of the tube L. So we can rewrite lambda is 4L. Remember, L is lambda by 4. So lambda is 4L. Okay. We know that velocity is frequency into lambda. So instead of lambda, we can write 4L. Frequency into 4L. Now we will just rewrite this equation for L. So V by 4F. 330 divided by 4 into 820 hertz. 0.1 meter, which is 10 centimeter. Which expression gives the definition of resistance? Very easy question. Potential difference divided by current. Okay. IB graph shows it's a semiconductor diode. Someone think it's a filament lamp, but even in opposite direction, it will conduct current. So even if you plug the otherwise, so it's not a filament lamp. Why it is a semiconductor diode? In only one direction, it allows the current, despite of negative voltage. Even if you have, it doesn't give current, allow current. That's a diode. Okay, interesting question. This diagram shows 6 identical resistors connected in a circuit. In which branch of the circuit is the most power dissipated? Super. So there are two equations to find the dissipated power. P is I square R or P is V square divided by R. We can use any of this formula. Let's use P is I square R. P equal to I square R. Now PQR and PSR, they are parallel to each other. So it's the same voltage. Whichever has least resistance will have more current in it. Okay. So if we take all the resistors are identical. So if we take resistance, one resistance is R, then PQR has R plus R plus R, 3R. Okay. PSR has 3 resistors. P and S has 1, S and R has 2, but these two in parallel. So the combined resistance will be 1 by R plus 1 by R, which is 2 by R, reciprocal. So R by 2, which is 0.5 R. So the total resistance between PSR is 1 R plus 0.5 R, which is 1.5 R. So the PQR has 3 R, PSR has 1.5 R, which is least resistance PSR. So this has least resistance. So this will have more current. So since PS and QR in series, they both will have same current. Whichever has the most resistance, it will dissipate more power. Why? Because P is I square R. Product is in multiplication. So PS has a single resistance R. SR has a double resistance, but the combined resistance is only 0.5 R. So PS has more current and more resistance in the entire circuit. So it will have the most power dissipated. Yeah, but the combination of most current and resistance. So it will have more power dissipated in the entire circuit. So SP, option D. If you take P is V square by R equation, also it will work. You have to be a little bit careful and more work. Why? PQR and PSR will have the same voltage, but you have to find how the voltage is divided. So PQ will have two part of voltage, QR will have one part of voltage, PS will have one part of the voltage, SR will have 0.5 part of the voltage. So you have to find the ratio. That's why P equal to I square R is more easy than P equal to V square by R. But still you will arrive at the same result. The diagram shows a circuit containing a thermistor, a fixed resistor, and a battery. Graph shows IV characteristics of both components. The battery has an EMF of 12 volt and negligible internal resistance. What is the current in the fixed resistor? Okay. The IV characteristic of both components are given. Circuit is given. Now in the circuit, voltage across the fixed resistor plus voltage across the thermistor must be equal to the total voltage, which is 12 volt. So this is the condition we infer from the circuit. And the total current is, let's take I. This will be the same current in thermistor, also in the fixed resistor. So now what we are looking in the graph is, for out of this 4 current, which current the combined voltage is 12 volt. That's what we are looking in the graph. So V1 plus V2 is 12 volt. Okay, I equal to I2 plus I1 equal to I2. Now we'll look. So we'll take all the currents. First, let's take D 0.80 milliampere. Here is 0.80 milliampere. Now the thermistor is 8.4 volt and fixed resistor is 12 volt. Combined voltage is 24.4 volt, which is not this case. Only 12 we should get. Similarly, for 0.48 milliampere, so it will be 7.2 plus 1.2, 14.4. So not. Let's check 0.40. Again, it's 6 volt plus 6.8 volt, 12.8 volt. Not. Now, if we take 0.36 milliampere, then it is in the middle between 5.2 and 5.6. So 5.4 volt. For thermistor also, it is in the middle between 6.4 and 6.8. So 6.6 volt. So this gives a combined voltage of 12 volt, which suits with our circuit conditions. So 0.36, 36 milliampere. So this is very easy. Okay, a cell is connected with a variable resistor. Internal resistance. What is internal resistance? This variable resistor's IV curve is given. Okay. No. So this is not, the variable resistor is connected to the cell and then its IV curve is given. Okay. The voltage across this variable resistor and current through the variable resistor. Yes. What is the internal resistance of the cell? We know that formula E is I into capital R plus I into capital R plus small r. So I into capital R plus I into small r. Okay, if you rewrite this equation. Now, what is this I into capital R? That is the voltage across the external resistor. I into small r is the voltage across the internal resistor. I mean, the internal resistance of the cell. That's what we are going to find. So let's rewrite this equation for internal resistance E minus IR divided by V. This IR we can infer from the graph. Okay, any points we can take corresponding voltage drop and the current in it. Okay, yeah. Now, okay. So now, how do we find EMF of the cell? When there is zero current, that is a EMF. In the graph where zero current, so 1.6 voltage is zero current. So that's the EMF 1.6 voltage. Okay. Now, so we can take any one point from the graph. So we can get the capital IR, that is the voltage across the external resistor. So I'm going to take this point, 20 milliampere when there is 1.2 volt in the external resistor. Okay. So capital IR is 1.2 volt and the capital I is 20 milliampere. So this is from the graph. You can take any point actually. So now let's substitute these values. For I 20 milliampere, capital IR 1.2 volt, E is 1.6 volt. So we will get how much you get? 20 ohms. So see, even if you take other value also, it will work. Let's maybe we can take 0.2 comma 70 milliampere. That will also still work. Yeah. Okay. Which list contains only fundamental particles? Option D. Okay. So electrons are not fundamental particles. Sorry, particles. A has neutrons which are not fundamental particle. B has protons which are not fundamental particles. C also has protons which are not fundamental particles. So only D. Quarks, positrons, neutrinos, and leptons. Which statement explains why alpha particles have discrete energies but beta particles have the continuous range of energy? Why? Because okay. Option C. Okay, we'll see why. First, when alpha particle emitted, the energy is shared between only the alpha particle and the whatever the resultant nucleus. But when the beta particles emitted, the energy is shared among, so whatever the parent nucleus and the beta particle and the neutrinos. So it's a three-body process. Okay. So the energy is distributed among these three. So the result, you will get continuous energies here and there, different energies. But alpha particle only with alpha particle and the resultant nucleus. So that's why alpha particles have discrete energies and beta particles have continuous energy. Okay, let's see why other options are wrong. Beta particles have much smaller mass than alpha particles, which means beta particles can be emitted with larger range of velocities. This has nothing to do with mass. This has to do with how many steps or what are the process and what are the particles involved. Alpha involved 2, beta involves 3. So no. Let's see B. Only alpha particles experience repulsion from the nucleus, which is dependent on the number of protons in the nucleus. Nope, this is also wrong. In tight space of nucleus, it doesn't matter whether it's you are alpha particle or beta particle. If you are not in the range of strong nuclear force, you will be repelled. So D, only the energy of the alpha particle is discrete because the composition of alpha particle is always the same. This is also wrong, but this does not explain why it emit just specific energy. Okay, so see, so this other lepton is nothing but neutrinos, neutrinos and antineutrinos. So option C is the right answer. Hadron consists of antiquarks that are all identical. What is the possible value in terms of the elementary charge E for the charge of 100? Okay, so consist of antiquarks that all are identical. Let's possibilities 3 antiquarks. Okay, we'll take antiquarks have either charge +1, 1/3 or -2/3. So when we have 3 particles, 3 antiquarks, so it has to be they are identical. Okay, so it's all +1/3. So if we add all, you will get +1/3, +1/3, +1/3. You will get 3/3, which is +1. Or if all of them -2/3, -2/3, -2/3, you will get -6/3, which is -2. -2 is not option here, so only +1. So +1E is the right answer. Last question. Why?